Straight into 3D. Straight into the. Okay, let's go. Let's do 3D. And there we go. Some of you aren't talking, but I can see you're typing in. You know, you're typing to everyone anyway, so people can see. If you want to do a type to me directly, where it says to everyone, if you press on the down arrow, you can choose the person you want to type to. But please don't start typing to people while we're doing our work here. Okay, so let's do these combinations of transformations. So now we're going to be doing dilations, reflections, and translations, it looks like. So let's see what it says. Example 1, find the equation of the image of y equals the square root of x under. Okay, so I've got a dilation of factor 2 from the x-axis, followed by reflection in the x-axis. Okay, so let's do it one at a time. And I know I've got it there, but I'm going to do it again. So I'm going to do it up here. X and y, that's what we're starting off with. That's what our rule says. The first one has a dilation of factor 2 from the x-axis. Now remember, when we do the dilations, we put it on the y part. So x remains the same, but we get a 2y. But then it says there's a reflection in the x-axis. So remember, reflection we still put on the y. So the x stays the same, and this becomes a negative 2y. So this is my x dash, my image, and this is my image for my y. So then I'm going to rearrange it to make x the subject. That's fine. And negative 2y equals y dash. Y will equal y dash divided by negative 2, or negative y dash divided by 2. That's how I got this line over here. So I didn't do all the steps, that's why I'm doing them here now. So next thing we're going to do is substitute into our rule. So y equals the square root of x, the image. We get y dash divided by 2, I'll just put the negative out the front there, equals the square root of x, dash, I'm going to remove the dashes from now on, so I'm going to do two things at the same time. I'm going to move the negative and this divide by 2. So divide by 2 becomes times by 2, so I get y equals negative 2 the square root of x. Whoever just joined us, you missed 3C. Okay, so that's how I get the image there. So there's my final answer, the image of the equation. Any questions there? Okay, part B. Get rid of that. Okay, we'll remove that one for now. So no one sees this. Okay. Part B, a dilation of factor 2 from the x-axis. So they give us this section to do. So from the x-axis. So my x and y, dilation of factor 2 from the x-axis, I write the dilation on the y part. Because from the x-axis, you've got it goes on the y. Then there's a translation of 2 units in the positive direction of the x. So the next one is going to be x plus translation of 2 units in the positive direction of the x, and at the same time I'll write 3 units in the negative direction of the y. So my y at the moment is 2y, there it is there, but I've got to subtract the 3, and that's how I get that part there. Any questions so far? So this is my x dash, x plus 2, rearranging this one, I get x equals x dash minus 2. This is my y dash, the 2y minus 3, rearranging this one, I get y dash plus 3, and I might as well divide by 2 at the same time. So that's how I get that line there. And now I'm going to substitute it in. I'll just remove this part and do it on there. So my y equals the square root of x, its image is going to be y dash plus 3 all over 2 equals the square root of x dash minus 2. We always make it y the subject because the original equation was with y the subject. So, and I'm going to get rid of the dashes at the same time. So I'm going to times by the 2 and then subtract 3. So this will equal 2 the square root of x minus 2. So I've times it by 2 And now I'm going to subtract 3, and that's my y equals, and that's how I get my final answer. Any questions on that one? Okay.
So you know how it says it goes 3 units in the negative direction of the y-axis?
Yes.
Why is it included in the y and not the x?
It's just a translation. So we're moving, you know, if we translate the x positive, we're moving x towards the positive side. If we translate x towards and along the negative x, remember, it's a translation. It's not a dilation or a reflection. So translations go on the
So it's only
axis.
dilations and reflections.
Correct.
Okay, so it's only dilations and reflections that go for the opposite
Correct.
value.
Yes, correct.
Okay, thank you.
Not a problem. All right. I'll leave it there for a minute in case someone, I think someone had joined us from somewhere else. Somehow they got my little invitation. Okay. Can I clear this? That's up there anyway, so you should be fine with it. The next one, example 2. Okay, example 2 says, find the rule of the image when y equals 1 divided by x cubed undergoes the following sequence of transformations. Okay, so the first one, dilation of factor 2 from the x-axis goes on the y. There it is. So starting always off with the xy goes on the y. Okay, the next part, followed, reflection in the x-axis. Reflection in the x-axis goes on the y. So there it is. I've got my reflection in the x-axis. It's now negative 2y. Then translation, and we always write dilations and reflections first if we are to write this up, and then the translations, just like they've done it. Okay.
Wasn't there an acronym for that, sir?
Sorry?
Wasn't there an acronym to remember that? It was like...
I can't remember it myself.
Okay. Wait, so what's the order, sir? Dilations, reflections, and then translations?
Correct.
Okay.
Or reflection and dilation, doesn't matter, but translations always last. Okay, then it says followed by a translation of 3 units in the positive direction of the x-axis. So at the x-axis, we're going to add the 3, and there we have, we've added the 3. And at the same time, 4 units in the negative direction of the y-axis, we're going to subtract the 4 from the y value. So there we go, from the y value, we'll subtract the 4. Okay, so rearranging, x dash equals x plus 3. So then we're going to rearrange this. I get x equals x minus 3. Rearranging this one here, I add the 4, so I've got my y dash plus my 4, and then I divide by my negative 2, so I get that one there. Is everyone happy with that? Substituting into the equation, so my y and then my x. And substituting this, I get y dash plus 4 all over negative 2 equals 1 divided by my x, which is x dash minus 3, and that's all going to be cubed. Okay. Make y the subject, so times by the negative 2, and then subtract the 4. So timesing by the negative 2, forgetting about the dashes, I get y equals negative 2 over the x minus 3 cubed, and then subtract the 4. And that's how I get my image there. Any questions on that one? Okay, I'll clear this. Example 3. It says sketch the graph of the image of the graph shown under the following sequences of transformations. Now you can take this in stages, okay, and trying to draw on this is going to be a little bit difficult, but anyway, I'll try and do my best. There's the answer down there so you can see it, but the first thing you do is reflect it in the y-axis. So what I would be doing is, in green, y-axis is there. Okay, so I would be doing this part like that. Then I would have the dot there, and I'd have that one there, and I'd finish the rest of this part off over here. Okay, so this would come up here, sort of do a loop and come back down like that. And this will be at negative, positive 2, sorry, not negative 2, but positive 2, because it's negative 2 there, it'll be at positive 2. So that's that first one. So I take it all in stages then, 2 units in the negative direction of the x and 3 units in the negative direction of the y. So we're moving that way, 2, and then that way, 3. So pick a couple of points and see what happens with them, and then just move them along. So it's going to be a bit hard for me to do here because I haven't worked everything out. And then the second part, do this part here, dilation of factor 2 from the y-axis. So remember, if it's factor 2 from the y-axis, okay, it's stretching the x's out. Okay, but that is the final answer. I'm going to leave that one because I know that if I try and do it on this screen, it's all going to be wobbly and I won't be able to work it out. And it's going to, you won't see anything. So I'm just going to clear that drawing because it's ridiculous and move on to the next one. So take your time doing those ones, or you can just do the whole thing, but I will take my time doing them separately. Example 4. For the graph of y equals x squared, sketch the graph of the image under the sequence of transformations. Okay, well, we can do the transformations first, and I think all I did was, yeah, it doesn't matter. We can do the transformations and then just sketch that. So let's do it like this. Translation of 1 unit in the positive direction of the x-axis and 2 units in the positive direction of the y-axis. Okay, well, I should have done this first, but anyway, we're going to go and do it like this. Come on, blue. All right, so x, comma, y will give me, oops, goes to. Dilation of factor 2 from the y-axis is going to give me 2x and y. That's that one there. Reflection in the x-axis is going to give me 2x and negative y. That's that one there. And then we're going to get 1 unit in the positive direction of the x-axis and 2 units in the positive direction of the y-axis, that part there. And then we can substitute in here and find our rule. Okay, once we found our x's and our y values. So I won't do all that working out for you, okay? But we can get our image rule. This is the image. This is part B, the image of the rule. And I can sketch that pretty easy because I know that this has a turning point at x equal to 1 and up 2. So up, that's 1 and 2 right there. And I know it's just a normal parabola. It's a positive parabola. So I know it looks like this. Okay, and I can find where it's going to cross the y-intercept. Put x equal to 0 in there. I get y equals 0 minus 1 squared. That's a 0 minus 1 squared plus 2. So that equals 3. Okay, very quickly you can pick another point like they did, 2, 3, and you can sketch it. So instead of trying to sketch from the image, you can find the image first and sketch that. Okay, so it's up to you what you want to do. Oh, no, I didn't do that. No, I didn't do that. I apologize. I did something different here. I did this part first, part A first. I subtracted the 1 unit, positive direction. So I've got my y equals x minus 1 squared, and I put the plus 2, positive direction of the y axis. So I added 2, and that's that sketch for this first part A sketch, the translations part. That's what I did there, the translations part. That's only the translations part. Now I'm doing part B, dilation factor of 2 from the y-axis. So from the y-axis itself. Okay, so if you're doing a dilation of factor 2 from the y, it gets stretched out, so the x values are multiplied by 2. So I've multiplied all the x values by 2. So 0 times 2 is still 0. The 1 times the 2 becomes the 2, and the 2 times the 2 becomes the 4. That's how all these numbers came about. That's 0, 3 up there. Okay, are you with me so far? Any questions? Okay, so let me clear this and move to the next part. And then I'm doing the reflection in the y-axis. So there's the reflection in the y-axis. Can I bring those two? Yep, there we go. So bringing those two together, I'm reflecting it sorry, in the x-axis, not the y-axis, must have been the x-axis. Reflected in the x-axis. So if that's 2, 2, that means that's going to be 2 and negative 2. Okay, so there's that point there. If this is 4 and 3, reflecting in the x-axis becomes 4 and negative 3. Remember the y's are changing, so there it is there. And this one here will be 0 and negative 3. So reflect it there. And then you've got your 3 points and you can draw your graph from there. And that's the final rule after all the transformations.